What's up, guys? Welcome back to Redstone Engineering. Today we will go over how to build a reprogrammable combination lock, which allows you to change the correct combination without having to modify the circuit itself. So to demonstrate, right now the combination for the door is 1 and 2. So as we can see, the door is closed, and if we hit 1 and 2, the door will open. If we hit 1 that's not 1 or 2, the door will close because that's no longer the correct combination. In order to reset the combination, we first need to type in the correct combination, which is 1 and 2, and then you can toggle program mode. This allows you to type in a new combination, which you can say 2, 3, and 4, for example. When you're done, you can hit program mode again, turn it off, and now the combination is 2, 3, and 4 instead of 1 and 2. So let's first start by adding the buttons. The first button needs to be toggle reprogram mode, and as we saw, this is what allows us to type in a new combination in order to change the combination to the door. The next button needs to be the reset button, and this allows us to clear the entries that we type in. Not to be confused with the reprogram mode button, it only clears the entries that we type in, but it does not change the combination itself. So for example, if the combination is 1 and 2 and we type a 3, we would need to hit reset in order to clear the entry that we have in the 3 position so that we can start again. The rest of the buttons are just the numbers that you have, and you can add as many of these as you'd like. I'm going to use 6, but the design is fully scalable, and you can add as many as you'd like. Alright, so now that we have the buttons laid down, we need to be able to store the values of the buttons for an indefinite amount of time until we reset. So the way I do this is I use an SR latch because it's just natural that you use one of these buttons to set it, and then you use that button to wipe the entire register. So the way I do it is I put pistons immediately on top of the block that the button's on, and then I put redstone blocks here, and then we bring out the reset line here, and then we put a piston here. The reset line will go all the way down, and the reset line is actually built like this, which we'll see here in a second. It's because we need to have a signal strength come in from below here, and we also need to have a repeater here. So we wire this like that, we grab the signal using the repeater here, and then we bring this all the way down. We then add the pistons here on every other one. And now we have our SR latches set. So now we can press like 1, 2, and 4, for example. And then it will store that value for an indefinite amount of time until we reset everything, and then we can start over. Alright, so next we need to make a register for the combination itself. I did this by bringing up the signal from the buttons using observers here. The reason it's observers and not just bringing up the signal directly is because you have to do transistors above anyways. So the fact that the observer fires when you hit either this button and the reset doesn't really matter. We put gold blocks on top of all of these, and then we put one more layer on top of all of them. We put redstone on top of this one so that it can grab the signal from the observer, and then we put repeaters here. Then we leave a gap here because the transistor has to go in the middle of this. So we put a gap on all of them. And then we put another repeater here. So this is basically just a transistor. We'll build the actual piston that comes down in a second. And then we put a piston facing this way. And now we just build the SR latch like we did below. We put the redstone block here. And then we put the reset line here. And then we put the other pistons on the other side. So before we can set up the transistors that'll connect these SR latches that go to the combination to these SR latches, we need to set up the reprogram mode button first. So because it's a toggle, it's fitting that we use a T flip-flop so that it acts as a toggle. I'm going to use this T flip-flop design, which is a Java Edition exclusive. So if you're using Bedrock Edition, you're going to have to use the one that uses the droppers and hoppers. It should be fine because there's nothing that really happens until it gets to here. So the fact that it's a little bit slower should be fine. We take this and we bring it up. And I put the torch here just because it will make the Y value correct. And then we go all the way across. And then we set up the redstone all the way down until we're right here. And then we put a repeater of delay 2. This comes in handy later when we have a reset happening, because when you reset this, these push back. But because these observers, these still fire, and we need this to pull up before it resets the combination. And then we put pistons here. and then we put some sort of opaque block facing downwards. So now when we hit the toggle button, you can see the transistors come down, and then when we hit it again, it goes back up. Alright, so now that we have the transistors down, we need to be able to reset the registers when they need to be reset. So the first one is we need to actually add the reset line to this one right here. So I would just put redstone across all this, and then we build this up pretty specifically, and I'll explain why here in a second. So we put it up by 2 blocks, and then we go up another one, and we only put 2 blocks here and leave a gap here. So the first reason is we need to put a transistor here, because we need to be able to control when the reset button actually resets the combination itself. Because if you're not reprogramming it, you don't want to hit the reset and try to reset the entries and then have it actually reset the combination. So we have a transistor here that goes before the repeater, and then we put a repeater here so that it can actually go through and work. And the reason we have it built up like this specifically is because we need to put a reset here. But first of all, we see that when we hit the reset button, it only resets this register and not this register. But when we're in program mode, it resets both registers. This is really convenient and it's really useful. However, we need to fix what just happened there by doing a couple more things. So the way we avoid the fact that this upper register gets reset into the on position by the observers like that is we put at least 3 ticks worth of delays here, like this. If you're using stud buttons, you can probably get away with less delay here, but 3 ticks should be good enough. So now when we press the button, it'll remain pushed until the observers do their thing, and it will stay there and actually reset the upper register. Next, we want to be able to reset everything when we turn on reprogram mode. So right now it's on, and I'm going to turn it off. But when we turn on reprogram mode, we want both registers to reset. And right now, it doesn't do anything with the reset. So the way we can do that is by putting a rising edge 1-pick pulse thing here. And this is a Java Edition exclusive, but you can do it horizontally in Bedrock Edition, and it'll work just fine. So now this will reset when we hit the toggle. So if we like press it a bunch of stuff and then hit the toggle, it'll reset everything. So the last thing that we want to reset is this register when we turn off reprogram mode. So right now reprogram mode is off, and we turn it on, it resets both of these registers. But if we type something in to the combination, we want this register to reset when we turn it off so that the combination isn't just stuck there. So the way we can do that is we do a rising edge 1-tick pulse here, if I can figure out how to build it, off of this torch here. And then we do it like this. We bring it around, and we do a 4-tick delay on this one or wherever before we get to there. And then we bring it all the way around to this reset line. And this is why this reset line is built so awkwardly, because we need to be able to get to that block and power it from below. Put a repeater there so we can strong power the block, and then we bring it all the way around. So now when we program something in, we don't reset that register, but we reset that register. So all you have to do is hit this button. That combination will stay, but then that will not be there. So then you actually have to go and type in the code. Alright, now that we have all the resets working properly and all the registers on the buttons are working properly, we need to be able to compare the entries to the combination. And basically, we need to be able to compare whether or not they're different or whether or not they're the same. And the best way to do this, I believe, is the next OR gate. So we need to first carve out some space here because the XOR gate takes some vertical space. So I start at this block here. So if the rest of the block was here, you start under it and then you give it some space. And then I go all the way down until you go to 1 block over so you can kind of see. And then I go down 2 blocks here and then I bring this further out so that we have space. So the hole needs to be 9 blocks wide on this level and 11 blocks on this level. This just helps it smooth out the XOR gates, and it needs to be as long as you have buttons. I put a 1 block gap on either side to make it easier to build the XOR gates, but it doesn't really matter. And now we need to grab the signals from these SR latches, which you can do just by putting redstone there, and then we bring it out. And we'll do that for every single SR latch. Like that. And then we bring it down to this block here. Likewise, we go up and grab these signals, and we bring down gold here, so we have it like this, and this is how we grab it. We're going to need to do this for all of them. And then we just have a signal that comes out. Now we need to build the XOR gate, and the XOR gates generally aren't that complicated space-wise. However, one block wide XOR gates can kind of be convoluted, so it'll look complicated, but it really just is an XOR gate. So it's not really important to know how the inner workings of the gate itself works, so I'm not going to try to explain each individual piece, but it is a little bit convoluted because it's one block wide, so I'm going to try to go slow so that it's clear. So first, we put a torch on the end of this, and you can actually pull out both of these signals further out. I just like having it compact. And then we build a pattern that looks like this, so that we can put a torch here, and then have a repeater go here. And we can do that on all of them. And then we put torches on all of them, and then the repeater that goes here. Okay. Now we need to put a block up here so that we can basically have this situation here. And I'm just going to actually build off of this so it's easier. Alright, and then we put a block here, and we put a block up here. Whoops. And then we put redstone on top of this, and then we put a torch on the end of this right here. And then we put a repeater here so that it can grab the signal from the torch itself. And then we put a block here. Alright, so that's the bottom part. Now let's do the top part. So the top part, we put a repeater here, first of all. And this will be more clear in a second. We put a block or two here, right? So that we have this situation right here. And we put redstone here. So this redstone grabs this torch's signal as well as this torch. This repeater doesn't actually interact with these two repeaters here, even though it might look like it. This is just to conserve space. So we do the same thing here. Put redstone on top of it. And then we put a block on this end, so that the repeater on top powers this block. And then we put a torch on the side, and then we put a torch here, and we do that on all of them. This torch will power this block, which it's meant to. And then we put a block on top of these repeaters. And then we put a repeater on top of this block so that it grabs a signal from this torch here. And then we put a block on top of this torch. And we actually bring this block out. And we put redstone on top of this so that it grabs the signal from either the repeater or the torch or both. And then we bring the blocks down to this level. And I'm just doing this so that I can easier do it. And we bring redstone down here. And then we put a torch here. And then we grab the signal by putting a block here, and then we put redstone on top of this block. So now we have an XOR gate. So we can test it by turning this input on, and it should turn the signal on. We can turn this signal off and turn this signal on, and it'll turn the signal on. And if we turn them both on, it should turn it off. And if they're both off, like we saw already, the signal's already off. So now we have all of the XOR gates. Alright, so now what we want to do at the end of all of these XOR gates is OR gate all of the signals together, which is basically just combining all of the signals. I'm actually going to replace these with repeaters, just so that we have the maximum signal strength there. So we combine all of these signals, and then what we do is we inverse the signal. And this signal right here is a signal that you use to like open your door or whatever you are unlocking. And the reason it's actually on right now is because we do have the correct code, and the correct code is all off, and we have all off. But if we go and press one wrong thing, then this one XOR gate will turn on, and it turns on the entire signal, and then it turns this off. So what this end result right here does is it makes it where they all have to be off. All of the XOR gates have to be off in order for this to be on, which means that if even one of these is wrong, then this is not on, which is exactly what you would want. All right, so the last few things that we want to be able to do is, first of all, make it where when reprogram mode is on, this door or whatever you have that's getting unlocked is off, right? Because when we are programming in the combination will always be right, because when we hit, like, say 1, that turns on and that turns on, so then the combination is correct, and then this will remain open. But we want the door to be closed, because you don't want people, like, walking into your house while you're trying to reprogram it. So what we want to do is force this signal to be on when reprogram it is on. So we can take the T flip-flop value from this block here, because it powers that block and it goes down, and we can force this signal to be on like that. However, because when we turn on reprogram mode, there's a lot of these delays that happen, so we actually want to smooth this out a little bit by putting a bunch of delays. And I just do delays like this, and this seems to work just fine. And then we go and force this to be on, right? So now the door is closed, regardless if the combination is correct. And then when that turns off, this turns off, and then the signal is no longer forced to be on. Now, the next thing that we want to fix is the fact that we can turn on reprogram mode right now, regardless if the combination is correct or not. But we want to be able to only turn on reprogram mode if the combination is correct, because you don't want someone just waltzing up and reprogramming your combination, because the security of that would be terrible. So what I do is I take this signal here, which is only off if the combination is correct, and I feed it into this piston here, because this piston has to be off in order for this button to work. So we can bring this signal over and actually do that and connect them, just like that. However, we have a problem with this, because now when we turn on reprogram mode forces this signal to be on, which will then force this signal to be on, and then you won't be able to turn it off, right? Because you've hit this button, nothing happens. So what we can do then is put a transistor here, and the transistor has to be inverted there. That makes this signal get cut off when this is on, right? Because if this signal is on, we want this to be off, because this means reprogram mode is on, and we need to be able to turn off reprogram mode regardless of what any of these signals are. So this transistor will do that, meaning we can turn off reprogram mode like we would normally. Now, the correct combination is on right now, but if we put in the incorrect combination, now the transistor is extended. This is incorrect, so it goes around and forces this to be up, meaning that we cannot turn on reprogram mode right now. All right, that's it. We have completely built a reprogrammable combination lock. As we can see, the door is off because the correct combination is not in. The correct combo is 1, 2. We turn on the door, and then we can program in a new combination, which you can say 2, 3, 4. And then we can turn off reprogram mode, and now the combination is 2, 3, 4. That'll be it for this video. I hope the explanations were clear and that everything made sense. If you have a suggestion or something that I could do in the future, or something I could clarify, let me know down in the comments. Have a great day, and I'll see you next time.